Hi all. So in this video we are going to learn the mechanical translational systems. We are going to find the transfer function of the mechanical translation system. So we know that the model is obtained by using three basic elements. That is, in mechanical translation system, every system can be constructed using three elements, that is mass, spring and dashpot. Actually, the weight of the body is represented by the element mass, that is M, and the elastic deformation of the body is represented by a spring. Then the friction is represented by the dashpot. Okay, so three elements: mass, spring and dashpot. So when a force is applied to a translation system, it is opposed by opposing forces due to mass, friction and elasticity of the system. So we have to write the force balance equation, that is, in that the applied force will be equal to the opposing force equation, and based on that we will derive the transfer function of a system. So these are some symbols we are using while we are deriving the transfer function. X is the displacement, v is the velocity and I is the acceleration, that is d square x by dt square, and F is the applied force, and Fm is the opposing force due to the mass, that is mass of the body, and Fk is the opposing force offered by the elasticity of the body. Fp is equal to opposing force offered by the friction of the body, and M is equal to mass, and K is equal to stiffness of spring, and B is equal to viscous friction coefficient. And the opposing force due to the mass, if you are considering an ideal mass element, that is, we are neglecting all the frictional and elastic deformation effects. Okay, we are neglecting that, only we are considering the weight of the body, that is mass. And if you are applying a force F in this direction, of course a displacement X will be there in the same direction of the applied force, and we know that the weight of the body, the mass, will provide an opposing force. Okay, opposing force corresponding to the applied force. So the force balance equation here is F, that is applied force equal to opposing force Fm, and we know that the equation for Fm is m into d square x by dt square, that is d square x by dt square. We know that it is A, that is from the normal equation F is equal to ma, we are deriving this equation m into d square x by dt square. And next we are considering an ideal dashpot element, that is ideal, we are considering the frictional effect only. And in this case also, the first condition, we are assuming that we are applying a force F in this direction and the other side of the dashpot is fixed. Okay, so in this case the opposing force due to the dashpot will be Fb, that is applied force equal to opposing force Fb, that is force balance equation, and the value of Fb will be equal to b into dx by dt, that is b into v. Okay, x is the displacement here, so b into dx by dt will be the opposing force due to the dashpot. And suppose if both the sides, okay, are not fixed, that is if both the sides are moving, then we have to consider the both displacement on the two sides. So in that case the opposing force Fp will be equal to b into d by dt of x1 minus x2. Okay, so applied force equal to opposing force Fb is equal to b into d by dt of x1 minus x2 will be the equation, opposing force equation. And next we are considering the elastic deformation element, the spring, and here also we are assuming that the one side of the spring is fixed and applying a force F here, and it's having a displacement of x, and we know that the Fk, the opposing force due to the spring, Fk will be equal to k into displacement, that is kx. So the force balance equation is F is equal to, that is applied force equal to opposing force Fk, it is equal to kx. And if both sides are moving, then the equation becomes F is equal to k into x1 minus x2. Okay, so these are the some basic equations of the mechanical translational elements. Okay, and for deriving the transformation, you have to know the sum of the Laplace transform of this term, that is Laplace transform of x of t is x of s, and Laplace transform of d by dt of x of t will be equal to s into x of s, and Laplace transform of d square x by dt square will be equal to s square into x of s. In these two cases we are assuming that the zero with zero initial conditions. Okay, the initial conditions are 0. Okay, so I hope all of you understand the basics of the mechanical translation system. So thank you.